All right, so problem number one, they want us to find the roots. So 5, 2. So what are the roots? What does that mean? Where it crosses the x-axis. All right. So this creates an asymptote. Agree? Because if you solve for the bottom, you get, if you plug -2 in, that becomes divided by 0. That's a big bad thing. So let's figure out this. So that becomes the difference of two squares, so x plus 4 and x minus 4. And it is under the square root. But what we can do with this, set that equal to 0, square both sides. So x equals -4, x equals +4. These are my roots. That's where it crosses the x-axis. That's just algebra 1 with the big radical in place. Okay? Problem number 2 gets a little goofy because they have given you the derivative already. And they want to know where it's increasing or decreasing. Okay, so problem number 1, A-okay? Problem number 2, because they gave you the derivative, what you should do is you go right to your sine line. Now, a couple of things that should stick out here. This is going to give me 0. Is that okay? This is going to give me 2. And then the denominator is just going to give me a undefined term if I make -3 down there. So I'm just looking at the top. All right. So let's think about this. What's a number that is left of 0? Just a number. It's not up there on the thing. Which one?
-1.
-1. Okay? So I'm going to think about if I were to take -1 and plug it in. Do you agree that's the right math? So -1 quantity squared is going to give me 1. -3 over 2. So is this answer going to be positive or negative? Negative. So over here is negative. Okay? Meaning it would be decreasing. Okay? What is the number between 0 and 2? It's number 1. So if I pick 1 and plug it in, I get 1 squared. 1 minus 2. 1 plus 3. So that's going to give me 1, -1 over 4. Is that going to give me a negative or positive? Negative. Hey, what took place at 0? What fancy new term did we talk about? Point of inflection. Okay? So this graph would have come down negative, evened out to give me a slope of 0, and then continued downward. What is a number to the right of 2? Yeah, so 3. So let's plug 3 in. 3 squared, 3 minus 2, 3 plus 3. It's going to give me 9 times 1 over 6. 9 times 1 over 6. Is that positive or negative? Would this give me a positive number or a negative number?
Positive.
Positive. So basically our graph is doing something like this. You know, it goes back up when it gets to this point. This is at 2. This is at 0. Okay? So that's what our graph looks like. So if we wanted to, I think this one says, what are the intervals? What are the intervals where it's increasing, decreasing? So from negative infinity to 0, it's decreasing. From 0 to 2, it's decreasing. And then from 2 to infinity, it's increasing. So why did it go to 0 for the decreasing? It stopped at 0 and started at 0. What's the slope at 0? What did I just say?
Decreasing?
What's the slope? Is it positive, negative, 0? So anytime you see you have the two important points, meaning the roots of the derivative, if it goes negative to negative or it goes positive to positive, something called a point of inflection took place. So right exactly at 0, the slope is equal to 0. It's a horizontal line. Okay? Then number 3, they want to know where this is increasing and decreasing. This is just the original function. They didn't give us the derivative. So we should find the derivative of this first. So I'm going to go g prime of x, which is going to give me 15x to the 4th minus 15x squared. Factor out. So I'm going to factor a 15x squared out of both. That's going to leave me x squared minus 1. So 15x squared equals 0. So that means x equals 0. That factors x plus 1 and x minus 1. I set both of those equal to 0, so I also get negative 1. And I get positive 1. So we can, real quick, do a sign line. And let's plug those values in. I have negative 1 here, I got 0 here, I got 1 here. Okay, we want to see where this graph is increasing or decreasing. Those values are important points. That's where the derivative is equal to 0. That means something is taking place on our original graph, whether it's a max, a min, or a point of inflection. But we don't know yet. So we can do our, the same thing we just did. I can do one of two things. I could plug a value into my original, and it can tell us something. So sometimes an easier way to do it, well, let's do it this way. So let's take negative 2. If I plug negative 2 in there, okay, negative 2 to the 5th. I don't care what it is. Is negative 2 to the 5th, is it a positive or a negative answer? Negative 2, negative 2, negative 2, negative 2, negative 2. Multiply 5 negatives in a row. Positive or negative? Negative. Now, this right here is going to give me a positive. This is a negative. But this is bigger. Because 2 to the 5th is 32. 32 times 3 is 96. 2 to the 3rd is 8. 8 times 5 is 40. So this is going to result here in a negative answer. Okay? Now, this is where you have to use a little bit more imagination. A number that is between 0 and 1, or 0 and negative 1, I'm going to take negative half and plug it in. Okay. Half times that. This is going to give me a negative answer. This will give me a positive answer. Which of these two answers up here are bigger? Is the 3 to the negative 1/2 to the 5th, is that a bigger negative number than negative 5 times a negative number? So negative half, that's negative 1/8. So this gives me positive 5/8. This gives me 3/32. Negative 3/32. Which number is bigger? Do you want 5/8 of a pizza, or would you like 3/32 of a pizza? 5/8 is a much bigger portion. So this is going to give me a positive answer. So the slope there is going to be positive. Then if I take 1/2, because 1/2 falls in between 0 and 1, 3, 1/2 raised to the 5th, minus 5 times 1/2 raised to the 3rd. So this is going to give me a positive answer, which comes out in this case to be 3/32. And this is going to be a negative answer, which comes out to negative 5/8. And we said that negative 5/8 is a larger number. We'd rather have 5/8. If I had a pizza and said I'll cut it into 8 slices, you get 5 of them. Or I had the same size pizza, cut it into 32 pieces, and I gave you 3 of them. Those 3 slices I give you, they're little thin things. Okay? So this is a negative answer here. And then if you pick a number to the right of 1, so maybe we'll pick 2. Okay? So 2 to the 5th is 32, that's 96. 2 to the 3rd is 8. So that gives me a positive answer. So this is kind of thinking about what our graph would look like. Bless you. It's doing this. Now, those points are curvy. It should flow like this. But that, for the most part, that weird looking W that's a neon color that you can't see unless you're like 17 inches from the screen, that's kind of what our graph would look like of our original function without even graphing it. Okay? So, not too bad. So I think we should do 3 more problems on here. And then I'll go over those tomorrow, and then we will continue with the millionaire adventure. Deal? All right, so let's look at worksheet, better color, worksheet 5-2, or 5.2. And will you take a look at 4, 5, 6? See how you can do with those. Okay? Period, italics, good. We got plenty of time. Good in the hood? Those of you that handed out those papers for me, thank you for